Hello there. This is a quick tutorial introducing Funkify, which is a function calling playground for large language models. I'm William from Spatial Pixel. I look like this, and these are part of our technical series of tutorials regarding spatial artificial intelligence. This tutorial covers what Funkify is, a little bit about what function calling is with large language models and why they're important for spatial AI, and then goes through a series of examples on how to write functions with Funkify. Function calling is essentially a way for large language models to trigger code execution. And that means for us, for spatial designers, architects, and computational designers, how can we get large language models and other modern AI to act in the physical world? So here, there's a prompt: configure the building's shades according to the current weather conditions. And what function calling lets you do is tell the LLM, hey, I have these functions available for you to call whenever the user asks for them. So if you need to get the current weather, I've got a function for that. And if you need to control anything in a building, I've got a function for that too. You can write these functions and little declarations that sort of give hints to the large language model that these capabilities are available. So it makes LLMs hugely customizable and makes them integratable into existing systems. It's a really powerful feature, especially for, again, interacting with the physical world. Let's get started. Funkify looks like this. What it allows you to do is chat with an LLM just like ChatGPT. And in fact, it uses OpenAI's models, OpenAI's API behind the scenes. It visualizes the function calls that occur, and you can define those functions right here. You can put function implementations here, not only the declarations that sort of hint to the large language model, but you can actually write JavaScript in Funkify. And that's what we built this for. It requires an API key from OpenAI. So go to your account, or sign up for an account rather, at platform.openai.com, and then create a new secret key here on the API keys page. Then you can paste that in right here in the upper right. This playground only runs in your browser. The OpenAI API key doesn't go anywhere. It's just stored in the browser itself. But still, I recommend to create a temporary one while you're using it, because a malicious browser extension or something could still potentially get at it. But paste your OpenAI key here and you're good to go. The way to get started is to populate the function definitions column with some example functions. So just click here. That will give you 2 functions, and we'll add more as time goes on. We'll also in the future add a way to create projects so you can store different sets of functions so you can iterate on them. But just to get started, the canonical example is always getting the current weather, which is a little boring, but it does demonstrate something that a large language model wouldn't know in its parameters, so to speak. So what is the weather in London, UK, for example? And here you can see Funkify gather the current weather. Apparently there was a problem to begin with, which is really interesting. But what you can see here is it triggers off the fact that the user, we are interested in the weather, then calls the function here. We ran into an error, but apparently it just picked right up and called the function again, which is really neat, and then returned the results here. This is what Funkify is for. You can define functions on the right. We'll look at this definition in a second. Add in prompts on the left and chat with GPT just like you would in any other chatbot. But you can actually see the functions being called and unpack them and debug them and so on and so forth. So that's that. You can pick your model that you want up here. These are all the models that support function calling as of today. This is June 2024. Some of these models support vision. You can select the detail selector here, with low detail having a low token consumption and high having a relatively high token consumption. Not all models support vision, but we'll get to this feature in a minute. And then finally, we have the function definitions on the right. So if you click on one of them, you can see how a function is defined. In this case, our function's name, the identifier is getCurrentWeather. All of this is in JavaScript again, so the name of the function should be JavaScript friendly. Then there's a description here, which describes the functionality that this function provides. This is really important because this is not just a kind of a notation for later reference or something like that. This is really a semantic description of the function. The large language model computes embeddings from this and uses it to know when to call the function. In this case, it's just telling the current weather given a particular location. That's the first thing you need for a function, is the name of the function and its description. Then, just like defining a function in code, you need to define its call signature. And that call signature consists of parameters. And these parameters are listed here. You can create, as many as you want. Here, it's just location, which is expected to be the name of a location as a string. So a name's location like London, UK. Funkify supports currently 4 data types, so strings, numbers, and then arrays of each. We'll get to this in a minute when we start writing custom functions ourselves. And then there's this flag that says required. This tells the LLM, even though you've received the signal to call this function, some of these parameters are absolutely required in order to achieve a successful function call. So you're able to tell the LLM, whatever you do, extract this information, and then call the function. In that case, what we've done is we've signaled to the LLM that 2 of these parameters, or latitude and longitude, are indeed required, and they're of type number. Just like the definition of the function overall, each parameter also takes a description, and this is also important. This is a semantic description that the LLM uses in order to compute a value for your parameter at call time. It will look at what the user is prompting, and then in this case, it grabs the location. And then for us, we actually need the latitude and longitude to make a successful call to our weather API. The great part about an LLM as sophisticated as OpenAI's GPT is that it will compute parameters for you, even though the user hasn't explicitly said them. So you can say location as New York City or Seattle, Washington, or even something more specific, and it will infer what the latitude and longitude are and then compute them and include them as part of the arguments to that function call, which is pretty cool. Our weather API is hosted by OpenMedio. So openmedio.com is a free weather API. They have a REST API and a lot of parameters that you can configure to get information about forecasts in any given location. And this API itself accepts a latitude and longitude. We can ask GPT, generate the latitude and longitude for us again, and then we just interpolate it into the implementation, into the URL on the right. I should have said this before, but the function definition is on the left here. And then the unique part about Funkify is that you can write the actual implementation in JavaScript here on the right. It gives you access to a number of the browser's APIs, like the Fetch API, for example, and a host of other things, which is goes a step beyond something like OpenAI's chat playground, where you can add functions. But here's this similar example to getting the weather, but you still have to write the JSON yourself here. Funkify does that for you. So you can just focus on what the implementation is, are the descriptions triggering the behaviors that you want, and so on and so forth. The neat part about function calling in general is you don't always have to explicitly say, hey, call this function. And you don't even really have to say what is the weather and use words that are in the description or the function name. You can just ask questions about the weather now. So something like, is it warmer in Lisbon, Portugal, or Paris, France? And a lot of GPTs now support multiple function calling. So we'll actually get a description that says, hey, user, you told me that you had these functions available for me. I need you to call this function twice. Here's the information you asked for, the location, the latitude, and the longitude. And so then calls the same function twice and then returns and does the comparison. Okay, in addition to this, when you're unpacking the function calls themselves, you see the visualization here. You get the function name, obviously, you get the parameters that you've asked for and the arguments that it has produced. And then you can also unpack the individual response here to see what the function has returned. And this is another part about LLMs that's really neat, is you can provide raw JSON strings as responses to the LLM, and it will just infer information from them. You don't have to structure the information. You don't have to pick it apart yourself. It can parse this and understand to a certain degree what's going on just from the raw JSON. So if we go back up here and see what the error was, it looks like it didn't follow through with the required parameters here. That's what went wrong with this function call. That's interesting. One final note about the implementation, if we look back at the current weather description, the way that you get access to the values on the left inside the implementation is through this variable called args that Funkify injects into the implementation on the right. You can say args.latitude in order to get the latitude of the location the user is talking about. So that notation is here for you. And that's about it. Let's look at a couple of other examples. There's another predefined function in Funkify called search academic commons. This is just a search function for a particular API hosted by the Columbia University libraries called the Academic Commons. It's here at academiccommons.columbia.edu, and they have developer resources here that you can access. There's an API documentation here in Swagger. So you just take a look, and there are a number of calls that we can make that essentially allow us to search through research that's been published by Columbia University faculty. We have a number of these parameters called out in this function, and we can use it here. This is the old implementation, so I'm going to swap out for a new implementation, and I'll upgrade this later. So the new implementation looks like this. Just a convenience function here that converts JavaScript objects into a URL-friendly string. We're going to use the keyword search feature of Columbia's Academic Commons. We're going to grab the first 10 results, and then just with one single keyword that it pulls out of a prompt, it'll return research entries from this API. Let's save the function and then ask it for something. What's the latest research? And let's say artificial intelligence from Columbia, and see what it comes up with. And there it is. As it's streaming here, if you don't want to follow along with the streaming, you can toggle the follow off here with this button, and it will continue to stream, but you can scroll on your own. So let's look at the response that it came up with. This is the raw response from the Columbia API. It has the abstract of 10 papers that it's pulled out with respect to artificial intelligence. So here, artificial intelligence in healthcare in India, parallel computer for AI, and so on and so forth. The next example that I wanted to do, let's look back at our checklist here. So we've said, what is Funkify? It's a web app that allows you to play with function calling. What is function calling itself? We talked about that a little bit. So you know that you need an API key, and we did the 2 examples already for the built-in functions. So we can cross these off our list. And then finally, let's actually write a new function from scratch, computing mortgage payments. You might know that LLMs are pretty bad overall at performing math problems or solving math problems. They're getting better at it all the time. But in some cases, you actually might want to provide your own function for a particular type of problem that you're working on. If accuracy is important in particular, you really want to ensure that things are being computed properly. Here in the upper right, you can create a new function by pressing the +F button, and it creates this dummy function. Let's give it a name. So compute mortgage payment. again, a description so that the LLM knows when to call this function. Like computes the monthly payment for a mortgage. And then we need a series of parameters. The way the mortgage payment's usually done, the most basic calculation, you need the principal, the interest rate, and the term. We can add each one of those parameters individually. So we can say args.principal, and then the type will be number. It's certainly required. And then we just give it a description, the principal value of the mortgage in USD. We can add another parameter for the interest rate, also a number. We can say it's required. Then we can say the interest rate of the mortgage as a percentage. And then let's say it's from 0 to 100. And then finally the term. So we'll say num years. We usually think about, sometimes the calculations are done with months, but we usually think about mortgages in years. So we can say the term, or the term of the mortgage in years. All right. We set up the function definition on the left with all the parameters and information that we want. Now we need an implementation on the right. Luckily enough, we're in an LLM chat, so we can just save the function and ask GPT for an implementation right here. So we can say, please give me an implementation to compute the implementation in JavaScript. Otherwise, it'll, in my experience, it usually defaults to Python to compute the monthly mortgage payment given, say a monthly mortgage payment, given the principal, interest rate, and term in years. Let's follow along. And here we go. And so it looks like the three values that we need are well defined: principal, interest rate, term in years. And here's the implementation. So let's just copy this out and put it into our function here on the right. And it's easy as that. So now all we have to do is call this function and pull out the arguments that we need in order to create a successful function call. So we say return, calculate mortgage payment, and then the first argument is the principal, so we say args.principal. The next argument is the annual interest rate, and it looks like that is also 0 to 100 because it's divided by 100 here. That's what we've also asked for, so we can say args.interest rate. And then finally, the number of years, args.numYears. We save the function. And let's just say I found a home for $250K USD. What would the mortgage payment be for a 3.5% loan for 30 years? Let's see if it calls the function. Yes, it calls the function. We can see the parameters that it's pulled out of the text here. And then the response is the raw number, $1,122, and there it is. So you can even, and now in classic sort of chat form, you can ask for modifications. What if I got a loan for 2.5%? It should call the function again with interest rate 2.5, and then it has the new monthly payment. You can imagine using that for a lot of different things. You could do computational geometry calculations. You could do more sophisticated statistics and so on and so forth. And it's easy enough to set up a function to call into math libraries and whatnot here in Funkify. And then in the future, when you copy your functions out, and I'll show you how to do that, how you would implement that with other, in your own systems and in your own code. Okay, let's do another example. Let's look back at our checklist. So we've done the computing mortgage payments example. So now computing cycling time with Mapbox. Okay, so particularly for urban designers, architects, computational designers, you're all probably familiar with Mapbox. Mapbox is a great company that provides a lot of data and APIs about the world around us, particularly geospatial data. It has a directions API that we can call into to to get directions and ask questions about distance and time and other various factors of the geospatial world. Let's call into the directions API. Let's look at an example. There are a lot of examples here around cycling and driving and so forth. So let's do an example with cycling and create a function to get the time it takes to take a bicycle from one point to another. Again, like OpenAI, you'll need an API key from Mapbox. So you can create that once you create an account. To create the function, we just do the same process. We can say compute cycling time as the name of the function, and then say for the description returns the time it takes to cycle between two given locations, A and B. And then let's look again at the API signature. And so the way that the locations work for cycling and driving as well, probably, it looks like it takes a semicolon delimited list of longitude and latitude. So that's what we'll ask Funkify and actually GPT to perform for us. So we can say, look, we can say point A as the first argument, and we'll say it's an array of numbers as the type. It's required. And we'll just say the longitude and latitude of the starting point A. And then we'll add another argument or another parameter, point B, also an array of numbers. And then that will also be required. We'll say it's the destination point. B, also an array of numbers consisting of the longitude and latitude. All right, I've already written out some of the implementation here. So I'm going to grab that and paste it in. Here we are. To format this properly, we grab args.pointA sub 0 and args.pointA sub 1 to get the longitude and latitude respectively. And we're just building up that same API call that we saw in the documentation, and then including the API, the access token, the API key as part of that. Let's take a look at what the response will look like. So the response is a JSON response. It has a top-level key called routes, and then a route object has a key called duration. That's the number of seconds it takes to travel that entire route. In our implementation, we parse the JSON just like all the other examples, and then we can grab the time, and then we can grab the routes object like this, and then we'll just return a string that interpolates the time and then adds the units on the end, seconds. So again, you can provide natural language responses or even structured responses here, and the LLM will understand what you mean. Save the function, and then let's ask it for some cycling time. How long would it take to cycle from, let's say, Battery Park City in Manhattan to Central Park? Oh, issue retrieving. Let's see what the undefined seconds. Uh-oh. Let's take a look at our implementation here. Oh, I should say duration. So I grab the first route and then say duration. Save the function. Let's do this again. 44 minutes, and the response says 2,670 seconds. Great. With the Mapbox API, you can imagine just following through with some of these examples even for how to ask for driving directions and querying various aspects of it. We could probably even try returning the entire response object and seeing if GPT will give us some interesting information from it. There's that. Okay, let's talk about some of the vision features that are exposed here in Funkify. Not all models support vision. A few of these do. If it doesn't, it'll just gray out the detail selector, like GPT 3.5 doesn't support vision features. what Vision allows you to do is it allows you to upload or reference images and ask questions about them. That's particularly interesting for us with respect to function calling because we can start to create relationships between what's in the image and what functions to call. In ChatGPT, you can upload an image. You can't really do that in Funkify just yet, but you can give it URLs to images and ask questions about them. So what do you see in this image? And I'll provide a URL to a public image from the Wikimedia Commons, and we'll see what it says. A quaint street in Portugal, of course. That's cool, but let's see if we can start to get Vision and function calling to interact with each other. I'm going to create a new function, and we'll just say, like, note public transportation. So if we were interested in images coming in, say, from either street photographers, webcams, and whatnot, we could ask for, maybe we're interested in the prevalence of public transportation means versus cars. And so we can say, notes when instances of public transportation are observed in imagery. And then let's add a parameter called description. Let's say it's required, and say a description of the means of transportation observed. So we're looking for things like streetcars, trains, and so forth. Okay. One thing that you can do in Funkify as well is you can test these functions, but you don't necessarily have to provide a complete implementation on the right. What you can do instead is just return a dummy value to ensure that the conversation continues, but you really haven't figured out how to implement a certain thing yet or what you want to do. What I like to do is say returns whether the function has succeeded or something to that effect. And then I just return the word success. You could put simple if-then-else statements here. You could put simple math equations like that. It doesn't have to be a full implementation per se. Please, and I'm going to say, please note any public transportation that you observe. Now, this is a bit of a cop-out, this little prompt right here. But I find that sometimes it doesn't always work to just leave the function definition. I get a higher success rate when I give it a little bit of a hint as to what I'm looking for. So let's see if it works. And it does. Look at that. It finds, it runs the vision, and then it actually calls the function at the same time it's running the vision model. So it says description, a red tram in a narrow street. That's great. That's how Vision works in Funkify. And one last feature of Funkify here at the very end is how do you get the work that you've done in Funkify out of it so that you can deploy the logic that you've written with these function definitions in a live app. And that's the export button in the upper right. So if you click this, you'll get the JSON definition of all of the functions that you've declared. This is the value that you need to provide in the tools key when you're calling into the OpenAI API. And so that's Funkify. We're going to continue to release features to this. The code is on GitHub. It's open source if you want to contribute or run it yourself. Please like and subscribe here if you're interested in more tutorials like this. We're trying to make AI really accessible, but particularly for spatial designers. So the subject matter and topics are going to get more and more spatial as time goes on. So I hope you find this playground useful, and thanks very much.